Question 1. Which of the following events would be least likely to occur? So let's work out the probability of these 4 events. So tossing a fair coin and obtaining a head, probability is 1/2. Rolling a standard 6-sided die and obtaining a 3, well that's 1/6. Randomly selecting the letter G from the 26 letters of the alphabet, we have a 1 on 26 chance of that occurring. And winning first prize in a raffle of 100 tickets in which you have 4 tickets. So that'll be 4/100, which simplifies to 1/25. So the fraction that's least is 1/26, and option C is the answer. Question 2. Which graph best shows data with a correlation closest to 0.3? Now 0.3 implies a weak positive relationship. So option C is out, and option B is out as well, because they look like negative relationships or even a 0 relationship in the case of option B. Option D looks like a strong positive relationship. So option D is out. In fact, if you were to draw a line of best fit by eye, you can see that the points are fairly close to the line. So that leaves us option A as the only solution. And in fact, if you were to draw a line of best fit by eye, we can see that the points are somewhat away from the line, but at the same time showing a positive relationship. So answer's A. Question 3. Luke's normal rate of pay is $24.80 per hour. In 1 week, he worked 14 hours at the normal rate, 4 hours at time and a half, and 3.5 hours at double time. He was also paid a wet weather allowance of $50 for the week. What was his pay for the week? So let's work this out one step at a time. The 14 hours at the normal rate is 14 multiplied by $24.80, which is $347.20. Now the 4 hours at time and a half is worked out by 4 multiplied by $24.80 multiplied by 1.5, which represents time and a half, which gives $148.80. Now for the double time component, we have 3.5 hours worked at double time multiplied by $24.80 multiplied by 2, and that 2 represents double time, and that equals $173.60. Now, adding all that together, and don't forget to add the $50 wet weather allowance, we get $719.60, so option D. Question 4. What is the value of theta to the nearest degree? Now notice that all 3 sides are given, so we can use either sine, cos or tan to find angle theta. So I've started by labeling the sides of the triangle. So the 135 meters is the hypotenuse, the 81 meters is the opposite side, and the 108 meters is the adjacent side to theta. So I'm going to use sine to find angle theta. So sine theta is equal to opposite over hypotenuse, so that's 81 over 135. But we need to make theta the subject of the formula. So this is where we use inverse sine, so that's the sine with the little -1 there. So theta itself is equal to the inverse sine of 81 over 135. So that's entered in that way in the calculator. Press equals, we get 36.8698, so on, and that rounds to 37 degrees. So option B. Question 5. Which of the following is 12t squared all over 3t times 2w in its simplest form? So I'm going to start off by writing the fraction in expanded form. So the numerator, 12t squared, can be written as 12 times t times t. And the denominator, which is 3 times t times 2 times w, can be written as 3 times 2 times t times w. And because all the terms are multiplied together, we can switch the order of the terms around. So simplifying it further, simplifying the numbers, so 12 over 3 times 2 is just 12 over 6, and t times t over t times w, we can cancel a t from the numerator and a t from the denominator. So we end up with 12 over 6 multiplied by t over w. Now 12 over 6 is just 2, and t over w is just t over w. And because we have a whole number multiplying a fraction, the whole number multiplies the numerator. So we end up with 2t over w. So the answer is option A. Question 6. A survey was conducted where people were asked which of two brands of smartphones they preferred. The results were 48% preferred brand X, 52% preferred brand Y. A graph displaying the data is to be included in a magazine article. The editor of the magazine wishes to ensure that the graph is not misleading in any way. Which graph should the editor choose to include in the article? So if we have a look at option A, we can see that the y-axis does not begin at 0. So option A is misleading, so it cannot be included. And for the same reason, option C cannot be included because its y-axis also does not begin at 0. So option C is out. So that leaves us options B and D. So we can see that with option B, the width of the columns is not consistent. So option B is misleading. So that leaves us option D as the only viable choice. But we can see that the y-axis for option D begins at 0 and the width of the columns is consistent. So option D is the answer. Question 7. In an experiment, a standard 6-sided die was rolled 72 times. The results are shown in the table. Which number on the die was obtained the expected number of times? So each one of these outcomes has a 1/6 chance of occurring. So the expected number of times should be 1/6 of 72, which is 12. And the outcome that occurred 12 times, according to this experiment, is 2. So the answer is option B, 2. Question 8. A high school has 100 students in each year group, year 7 to year 12. A survey is to be conducted to determine the average number of text messages sent per month by students at the school. Which of the following would provide the most representative sample for this survey? Now we need to choose a sampling method that ensures as much as possible that each year group is fairly represented. Now since each year group consists of 100 students, so each group is exactly the same size, we need to pick a sample from each year group such that each of the sample sizes are identical. So if we choose 10 students from year 7, we need to choose 10 students from year 8, 10 students from year 9, and so on. So the sample size from each group needs to be identical as well. So options A and B are clearly out. Option D is out, in fact, because this doesn't ensure that the sample chosen from each year group is going to be identical. So that leaves us option C, 20 students chosen at random from each year group as the most representative sample. So the answer is C. Question 9. Lynn invests $1,000 for a term of 15 months. Interest is paid at a flat rate of 3.75% per annum. How much will Lynn's investment be worth at the end of the term? Now firstly, it's flat rate interest, which means simple interest. We need to use the formula I equals PRN to calculate the interest earned on this investment, and we add that interest to the principal to then work out the value of the investment at the end of the term. The other point to note is the time period is measured in months. We'll either need to convert that into years or convert the interest rate per annum into an interest rate per month. So I'm going to use the formula I equals PRN to calculate the interest earned. So I equals P, which is 1,000, that's the principal invested, multiplied by the interest rate per annum, multiplied by the number of years. Now, since the time period is measured in months, to convert months into years, we need to divide that by 12. So I've chosen to keep the interest rate as is, but convert 15 months into years. And I get $46.88 worth of interest. That needs to get added on to the principal and we get $1,046.88. So the answer is option A. Question 10. Students studying vocational education courses were surveyed about their living arrangements. One of these students is selected at random. What is the probability that this student is male and living with his parents? Now from the two-way table, we can see that 155 students were both male and living with parents. So to work that out as a probability, we take 155, we divide it by the total number of students surveyed, 505, and then we multiply that by 100 to convert that into a percentage. Like so. You end up with 30.693%, and that rounds to 31%. So the answer is option A. Question 11. An enterprise agreement has the following annual salary arrangements. George's employer pays 6% more than the enterprise agreement. He is on step 3 and receives an allowance for leader 2. What is George's gross monthly pay? Now step 3 means that his base salary is $45,000 per year, and leader 2 means that his leadership allowance is $7,500 per year. So adding those two together, George is on $52,500 per year. However, George's employer pays 6% more than the enterprise agreement. So we need to increase $52,500 by 6%. And we can do that easily by multiplying $52,500 by 1.06. And we get $55,650 per year. A we want George's gross monthly pay. So of course we need to divide that by 12. And we get $4,637.50, option D. Question 12. A square pyramid fits exactly on top of a cube to form a solid. What is the volume of the solid? We can see that it's a composite shape, so we have a cube and a pyramid. Now the volume of the cube is easy enough, so it's 9 times 9 times 9, 9 cubed. However, the volume of the pyramid requires a little bit of extra work. We need the area of the base, and we need the height of the pyramid to be able to work out its volume. So the area of the base is 9 centimeters by 9 centimeters, which is 81 square centimeters. The next thing we need is the height of the pyramid, which is 19 centimeters minus the height of the cube, which is 9 centimeters. And that gives us 10 centimeters. Finally, we can work out the volume of this composite shape. So volume is equal to 9 cubed, so that's the volume of the cube, plus 1/3 multiplied by the area of the base, multiplied by the height of the pyramid. And that gives us 999 cubic centimeters. So option B. Question 13. Polly borrowed $11,000. She repaid the loan in full at the end of 2 years with a lump sum of $12,000. What annual simple interest rate was she charged? And the first thing to note is the amount of interest that she paid. So she borrowed $11,000, paid back $12,000, which means the interest is $1,000. Now it's simple interest, so we can use the formula I equals PRN to calculate the annual rate of interest. So I, which is $1,000, that's the interest, is equal to the principal, $11,000, multiplied by R, the annual interest rate, multiplied by N, which is the number of years, so it's 2 years. Now we need to rearrange this equation to make R the subject of the formula, so we can divide both sides by 11,000 and by 2, and we can do that at the same time because everything on the right hand side is just being multiplied together. So we could do 1,000 divided by 11,000 divided by 2 all in one step. And that equals 0.0454545. It's recurring. But we need to convert that into a percentage, so we need to multiply that by 100. And we end up with 4.55%. So it's option B. Question 14. The July sale prices for properties in the suburb were $552,000, $595,000, $607,000, $607,000, $682,000 and $685,000. On the 1st of August, another property in the same suburb was sold for over $1 million. If this property had been sold in July, what effect would it have had on the mean and median sale prices for July? So we're going to add another score that's much larger than the existing scores and then take the average of that. So clearly $1 million being much larger than all the others will increase the mean. So the mean will change. But let's see what happens to the median. So currently we have 1, 2, 3, 4, 5, 6 scores. So that's an even number of scores. So the median will be the average of the two middle scores. Since these scores are in order, we don't have to sort them. So the average of 607,000 and 607,000 is just 607,000. So if we add an extra score, so let's add this pronumeral x here to represent $1 million. We have 7 scores, so 1, 2, 3, 4, 5, 6, 7. The median now, because it's an odd number of scores, the median is the 4th score. 1, 2, 3, 4. So the median is still $607,000, even though we've added this extra $1 million. So the mean has changed, but the median has stayed the same. So it's option C. Question 15. The frequency histogram shows the number of goals scored by a football team in each game in a season. What was the mean number of goals scored per game by this team? So I'm going to use the stat mode on the calculator to enter in this data, and the calculator will work out the mean for us. So if we press mode and then stat, 1 var, so number 1, you notice that we have a column for the scores but no column for the frequency, so we need to enable that in this calculator. So shift mode, so that takes us to our setup screen. Scroll down. Number 4, stat, if you press that, frequency on, so number 1. You can see now you have the frequency column, so let's enter in this data. So 3 goals scored, 4 goals scored, 5 goals scored, 6 goals scored, 7 goals scored, and 8 goals scored. So scroll across to the frequency column, and the number of games where 3 goals were scored with 3 games. 4 goals scored, there were 7 games. 5 goals scored, there were 5 games. 6 goals scored, there was 1 game. 7 goals scored, no games. And 8 goals scored, there were 4 games. Now press AC, and then shift 1 to bring up our stat menu, and then number 4 var, and number 2 x bar, and equals, and we get 5. So the answer is option C. Question 16. The shaded region shows a quadrant with a rectangle removed. What is the area of the shaded region to the nearest square centimetre? Now recall that a quadrant is 1/4 of a circle, and the area of a circle is pi r squared. So the area of a quadrant is 1/4 multiplied by pi r squared. But before we consider the area of the quadrant, we need the radius of this quadrant. And the radius of the quadrant is 3 plus 6, which is 9 centimetres. Now, to work out the area of this composite shape, we work out the area of the quadrant, and then we take away from that the area of the missing rectangle. So area is 1/4 multiplied by pi r squared, so pi multiplied by 9 squared, minus the area of the rectangle that's been removed, which is 6 multiplied by 2. And we get 51.617, dot, dot, dot. And to the nearest square centimetre, that's 52 square centimetres. So it's option B. Question 17. Triangles ABC and DEF are similar. Which expression could be used to find the value of x? Now, since the two triangles are similar, that means that one triangle is an enlargement of the other. That also means that corresponding sides must be in the same ratio. So for example, DF over AC must equal DE over AB. And I've written that here. So side DE, so the hypotenuse of the larger triangle over the hypotenuse of the smaller triangle is equal to DF over AC. So they're the corresponding shorter sides. Now DF is 15 and AC of course is 10. And DE is X and AB is Y. Now we need to rearrange this equation and make X the subject of the formula. So multiplying both sides by Y, we have X equals Y multiplied by 15 over 10. And that means option C is the answer. Question 18. Two unbiased dice, each with faces numbered 1, 2, 3, 4, 5 and 6 are rolled. What is the probability of obtaining a sum of 6? Now firstly, there are 36 possible outcomes. So 1 plus 1, 1 plus 2, 1 plus 3, so on and so on, all the way through to 4 plus 6, 5 plus 6, 6 plus 6. Now we could do a two-way table, but that would take too long. So I think it's just easier to note that there are 36 possible outcomes. So let's see what the favoured outcomes are. So the favoured outcomes, for example, you could roll a 1 and then roll a 5. So 1 plus 5 is 6. Alternatively, you could roll a 5 and then roll 1. We could roll a 2 and a 4, so that adds up to 6. Or we could roll a 4 and then a 2. And of course, we could roll a 3 and a 3. So there's only one way that that can happen. So there are 5 favoured outcomes. So the probability of rolling a sum of 6 is 5 over 36. So option D. Question 19. A logo is designed using half an annulus. What is the area of the logo to the nearest square centimetre? And we can see here that we have a large semicircle, and from that we're going to take away a smaller semicircle. So we'll need the radius for both the large semicircle and the radius for the smaller semicircle. So let's work that out first. Now the radius of the large semicircle is 5. Diameter is 10, half of that is 5. So that's how we work out the radius. Of course, it's half the diameter. Next, we'll need the radius of the smaller semicircle. So it's going to be 10 minus 3 minus 3. So 10 minus 3 minus 3 is 4. That's the diameter of the smaller semicircle. Half of that is 2. Next, we can work out the area of this particular composite shape. And that'll be pi times r squared. So this is the large r, 5 squared, so the large semicircle. I'm treating it as a circle at first. I'll be dividing by 2 at the end because we are dealing with semicircles. So let's work it out as if it was a whole circle. So pi r squared, pi times 5 squared, minus pi times 2 squared. So this is the small r, the smaller radius. And of course we need to divide that by 2 because we are dealing with semicircles. And that gives us 32.986 dot dot dot. And of course that rounds to 33 square centimeters, correct to the nearest square centimeter. So option B. Question 20. There are 60,000 students sitting a statewide examination. If the results form a normal distribution, how many students would be expected to score a result between 1 and 2 standard deviations above the mean? Now you may assume for normally distributed data that 68% of scores have z-scores between -1 and 1, 95% of scores have z-scores between -2 and 2, and 99.7% of scores have z-scores between -3 and 3. That's known as the empirical rule. Now, first thing to note is that 34% of scores lie between z-scores of 0 and 1. Since, of course, 68% lie between -1 and 1, so obviously I've halved that range there, which will mean I'll have to halve that percentage there as well. And also, half of 95%, which is 47.5% of scores, must lie between z-scores of 0 and 2. Now you can see probably what I'm about to do next. Of course, I'll need to subtract one from the other because we're interested in the number of scores between 1 and 2 standard deviations above the mean, not between 0 and 1 or between -1 and 1. So it's like working out a composite area. And to work out the number of scores, it's 47.5% So that's the number of scores between 0 and 2, and we're going to subtract from that the number of scores between 0 and 1, and that's 34%. And we're going to multiply that by 60,000, since there are 60,000 students. And we obtain 8,100. So the answer is option A. Question 21. Which equation correctly shows R as the subject of S equals 800 outside of 1 minus R? Now the first thing to note is that 800 is multiplying this bracket 1 minus R. So I've just written it explicitly as 800 multiplied by 1 minus R in brackets. Next, we'll need to expand the brackets. That means removal of the brackets by multiplying every term inside the brackets by 800. And we get S equals 800, so 800 multiplied by 1 gives us 800. And 800 multiplied by negative R gives us negative 800R. Now we need to make R the subject of the formula. So I'm going to add 800R to both sides, and in doing so, this negative 800R effectively moves over and becomes positive 800R. So we have 800R plus S equals 800. So this 800 here stays intact, it stays where it is. Now we need to subtract S from both sides. So this positive S, you could move that over and becomes negative S, or just subtract S from both sides. So we have 800R, so that stays where it is equal to 800 minus S. So this plus S becomes minus S on this side. And of course we'll need to divide both sides by 800 to have R the subject of the formula. So R equals 800 minus S all over 800. So the answer is option A. Question 22. Leanne wants to build a rectangular vegetable garden in her backyard. She has 20 metres of fencing and will use a wall as one side of the garden. The plan for her garden is shown, where X metres is the width of her garden. Which equation gives the area A of the vegetable garden? So firstly, we have 20 metres of fencing, which encompasses these three sides. So that's two widths and a length. Now, in order to work out the area of the vegetable garden, and this being a rectangle, of course, we need the length and of course the width. So let's work out the length first. And the length is worked out by taking 20 metres, which is the total amount of fencing, minus X, which is one of the widths, but then we need to subtract X again, which is the other width. And combining the like terms, we have length equals 20 minus 2x metres. Now to work out the area, we take the width and then multiply it by the length. So area is equal to 20 minus 2x multiplied by x, and expanding the brackets, so multiplying the x by each of the terms inside the bracket, we have x times 20 is 20x, and x multiplied by negative 2x is negative 2x squared. So the expression for the area of this vegetable garden is 20x minus 2x squared, which is option D. Question 23. Zena opened an account to save for a new car. 6 months after opening the account, she made her first deposit of $1,200 and continued depositing $1,200 at the end of each 6-month period. Interest was paid at 3% per annum, compounded half yearly. How much was in Zena's account 2 years after first opening it? Now the first thing we need is the interest rate per period. So it's quoted at 3% per annum, but it's compounded twice a year, so every half year. So we need to divide 3% by 2, and that gives us R is 1.5% per 6 months. Now we can answer this question as a recurrence relation. So let's start off with A0, which is the amount that Zena has in her account right at the very beginning. So she has nothing in that account. Now, at the end of the first 6-month period, or the first half year, we take whatever we have in the previous period, and we know that A0 represents $0, we multiply that by 1 plus 1.5%, so increasing that by 1.5%, and of course increasing 0 by 1.5% is just 0, and then she deposits $1,200, so that's the plus 1,200. So at the end of the first 6 months, Zena has $1,200. Now let's work out how much she has at the end of the second period, which is at the end of the first year, so the second lot of 6 months. So A2 is equal to whatever she has in A1, so $1,200. That'll be increased by 1.5%, so we multiply by 1 plus 1.5%, so that increases it by 1.5%. And then she deposits another $1,200. So at the end of the first year, so that's after 2 lots of 6 months or 2 compounding periods, she has $2,418. Let's repeat this again. So at the end of 18 months, so the third compounding period, A3, we take whatever she has in A2 or at the end of A2, so 2,418. We're going to increase that by 1.5%. So we're going to multiply 2,418 by 1 plus 1.5%. And then we're going to add on another $1,200 because she deposits another $1,200 at the end of that compounding period. And we get $3,654.27. Now let's work out how much Zena has at the end of 2 years. So after 4 compounding periods, we take what we have at the end of A3, so at the end of the third compounding period, $3,654.27 multiplied by 1 plus 1.5%, so that increases this amount here by 1.5%. And then Zena deposits another $1,200. And at the end of 2 years, she has $4,909.08. So the answer is option A. Question 24. What is the value of theta to the nearest degree? Now we can see here that we have a right angled triangle, and inside the right angled triangle we have a non-right angled triangle with 2 known sides and a known angle. Now to find the angle theta, we will need to find this angle here and then use the angle sum of the right angled triangle, so the larger triangle, which is obviously equal to 180 degrees being a triangle, to then work out angle theta. So before we worry about theta, we need to find this angle here. I'm going to call that angle alpha. Now, we have 2 known sides, a known angle, of course, and we have a known side angle pair. So that's a side and an opposing angle that's known. So we can use the sine rule. And by the sine rule, sine alpha over 82 is equal to sine of 26 degrees over 100. And we need to solve for alpha. So multiplying both sides of the equation by 82. So this division by 82 becomes a multiplication by 82 when we move it over to the other side. So we have sine alpha is equal to 82 multiplied by sine 26 degrees over 100. And making alpha the subject of the formula by taking the inverse sine of both sides. So alpha is equal to the inverse sine, so that's shift sine on the calculator, inverse sine of 82 multiplied by sine 26 degrees over 100, and that gives us 21 degrees correct to the nearest degree. So this is 21 degrees. Now we can use the angle sum of the right angled triangle to find the size of angle theta. So theta is equal to 180 degrees minus 90 degrees minus 26 degrees minus 21 degrees, and that equals 43 degrees. So the answer is option C. Question 25. A net is made using 4 rectangles and 2 trapeziums. It is folded to form a solid. What is the volume of the solid in cubic centimeters? Now the first thing to note that if this solid was folded up, it would actually form a prism. And it'll form a prism where the cross section is a trapezium. So think of the cross section like you're going through a tunnel, and around you it's exactly the same shape as you walk through the tunnel, from one end to the other. So in this case, the tunnel is a trapezium-shaped tunnel from one end to the other. So to find the volume then of this shape, we need to find the area of the cross-section, which is the trapezium, and then we multiply that by the depth of the tunnel or the height of the prism, whichever way you want to look at it. So the area of the trapezium cross-section, so let's move the page up a little bit, is half multiplied by the distance between the parallel sides, which is 8 centimeters, multiplied by 11 plus 5. So that's the sort of the bottom side of the trapezium plus the top side of the trapezium. In fact, if I turned the shape this way, you can see the trapezium a lot easier this way. So there's the height of the trapezium, 8 centimeters. The top of the trapezium is 5 centimeters, so that comes from this edge here. So 5 and 5 there. So when they fold up, they meet, of course. And this side here would be 11 centimeters. And that equals 64. And to find the volume, we take the area that we just found, which is 64, multiplying it by the height or the depth of the prism, which is 9 centimeters. And we get 576 cubic centimeters. So it's option D. Question 26a. Triangle PQR is shown. Find the size of angle Q to the nearest degree. So we have an unknown angle and 3 known sides, which means we need to use the cosine rule for angles. So cos of angle Q is equal to 53 squared plus 66 squared minus 98 squared all over 2 times 53 times 66. And of course we need to make Q the subject of the formula because that's the angle we need to find. But before we do that, we can simplify the fraction on the right hand side. So cos of Q is equal to negative 813 over 2332. So Q is equal to the inverse cos, shift cos on the calculator, of negative 813 over 2332, which gives us 110.40 ... degrees. And of course, rounded to the nearest degree, that'll be 110 degrees. Question 26b. Write down a set of 6 data values that has a range of 12, a mode of 12, and a minimum value of 12. So let's work backwards. Let's start off with the minimum value of 12. So that means the first score in this set of 6 scores is 12. Now let's consider the range. Now the range is 12. So that means the difference between the maximum and the minimum value is 12. So if the minimum is 12, that means the maximum must be 24. Now for the numbers in between. The set of 6 data values has to have a mode of 12. Now the mode represents the most common score or the most popular score. So we have a range of responses here. So we know that the number 12 or the score of 12 has to be the most common. So perhaps I could write a second 12 there. But there's nowhere in the question that states that the scores have to be different or distinct. So I decided one response could be just fill the middle 4 scores with just the number 12 or the score of 12, and that answers the question. You could have another response, for example, 12, 12, 13, 14, 15, 24, that will answer the question, or any set of numbers in between such that all 3 conditions are satisfied. Question 26c. The probability that Michael will score more than 100 points in a game of bowling is 31 over 40. So part 1. A commentator states that the probability that Michael will score less than 100 points in a game of bowling is 9 over 40. Is the commentator correct? Give a reason for your answer. Now this statement here, more than, does not include Michael scoring exactly 100 points. So we need to think about what is the complement of more than. Is it less than? Or is there something else we need to take into account? Now clearly, the complement of more than is less than or equal to. So the commentator did not take into account the probability that Michael scores exactly 100 points. So the commentator is wrong, since the complement of more than is less than or equal to. And the commentator does not take into account the equal to part here. Part 2. Michael plays 2 games of bowling. What is the probability that he scores more than 100 points in the first game and then again in the second game? So let's call this the probability of a win-win. So let's say that Michael scoring over 100 points is a win. And they're independent events in that the first game does not affect, or in theory does not affect, Michael's performance in the second game. So we can just multiply the 2 probabilities. So probability of a win-win is equal to 31 over 40. So that's the probability of Michael scoring more than 100 points. That's the first game, multiplied by the probability of winning more than 100 points in the second game. And that gives us 961 over 1,600. Question 26D. A section of Jim's electricity bill is shown. Part 1. What is the value of A? Now the difference between the current reading and the previous reading gives us the energy used. So 531.2 minus 274.8 gives us 256.4 kilowatt hours. So in other words, A minus 560.9 equals 523.5. So let's reverse that. 523.5 plus 560.9 gives us the current reading of 1,084.4 kilowatt hours. So part 2, how much will Jim save if he uses 154 kilowatt hours of energy at the off-peak rate rather than at the peak rate? So this is the peak energy charge, or the peak rate here for peak time, and here's the off-peak energy charge there, 9.6 cents per kilowatt hour. So the difference between these two will give us the cost saving per kilowatt hour, and then we can multiply that by the number of kilowatt hours to give us the total cost saving. So 154 kilowatt hours multiplied by the peak energy charge minus the off-peak energy charge. So the difference between the two is the cost saving per kilowatt hour. Note that that's in cents, and that gives us 5,878.18 cents. Of course, we need to divide that by 100 to convert it into dollars. And Jim stands to save $58.78. Question 26E. Kimberly has invested $3,500. Interest is compounded half yearly at a rate of 2% per half year. Use the table to calculate the value of her investment at the end of 4 years. Now firstly, interest is compounded half yearly, which means we need the half yearly interest rate. And that's already given as 2% per half year. So there's no need to divide the 2% by anything. So we just leave the 2% as is, which means we'll be referencing this column here, the 2% column. Now to determine the number of periods. The investment goes over 4 years. Interest is compounded half yearly, which means there's 2 compounding periods per year over a period of 4 years, which gives us a total number of compounding periods of 8, since it's 2 half years per year over 4 years. That means R is equal to 2%, N is equal to 8, which means the interest factor that we need is this one here, 1.172. So to calculate the future value of Kimberly's investment, future value is equal to the principal, 3,500, multiplied by the interest factor, 1.172, to give us a future value of $4,102. Question 26F. Jason travels to work by car on all 5 days of his working week. leaving home at 7 a.m. each day. He compares his travel times using roads without tolls and roads with tolls over a period of 12 working weeks. He records his travel times in minutes in a back-to-back stem and leaf plot. Now what I've done already is I've annotated this back-to-back stem and leaf plot. I've calculated the range and also the shape of the distribution for each side of this back-to-back stem and leaf plot. We will need this for part 3 of this question. So part 1, what is the modal travel time when he uses roads without tolls? Now the answer is 52 minutes. So how do we get 52 minutes? Let's refer to this side of the back-to-back stem and leaf plot, so without tolls. We look for the leaf that occurs the most often, sort of one after the other. And we can see here that the number 2 occurs one after the other most often. So this occurs 4 times in sequence. So combining the leaf with the stem of 5, that gives us 52 minutes. Now part 2, what is the median travel time when he uses roads without tolls? Now there are 30 scores on this side of the back-to-back stem and leaf plot. It's an even number of scores, so if we divide that by 2, we get 15, which means the median is the average of the 15th and 16th scores. So counting 15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So that's 50 and 51. We need to take the average or the mean of 50 and 51, which is 50.5. Hence the median travel time is 50.5 minutes. Now part 3, describe how the two data sets differ in terms of the spread and skewness of their distributions. So first of all, if we consider the spread of scores, we can see clearly that without tolls it's quite narrow. And calculating the range, so that's 61 minus 39, we get a range of 22 minutes. If we compare that with the range of with tolls or travel time with tolls, we get a range of 55 minutes, so that's 90 minus 35. So clearly the spread of scores is much greater with tolls compared to without tolls. Now looking at the skewness or the symmetry or lack thereof, we can see that without tolls the distribution's fairly symmetrical. But with tolls, we can see that the distribution is positively skewed. So there's a tail here on the sort of the positive side of this distribution where the numbers are greater or the scores are larger. And they seem to be bunched, or the scores seem to be bunched more toward the negative side. However, it's positively skewed because we look where the position of the tail is. In fact, if I turn the back-to-back stem and leaf plot around, we can see here that the tail is toward the positive side of this distribution, or toward on the scale, the positive side of the scale. So in answering this question and wording the question, you will need to take into account these facts. Question 27a. Lucy went for a bike ride. She left home at 8 a.m. and arrived back at home at 6 p.m. A graph representing her journey is shown. Part 1. What was the total distance that she rode during the day? So what we look for is the point that's furthest away from the x-axis. So at this point here, Lucy's at home, so 0 kilometers from home, so she's at home. At 10 a.m. she's 20 kilometers from home. At 11:30 she's 30 kilometers from home, and at 12:30 p.m. she's 35 kilometers from home, and that represents the furthest distance away from home. But from this point she then makes her way back home again. So the whole round trip is 35 kilometers plus 35 kilometers back home to give us a total of 70 kilometers. So part 2, how much time did Lucy spend riding her bike during the day? And from the travel graph, any horizontal section represents time that Lucy is not riding her bike. So from 8 a.m. to 6 p.m. we have 10 hours total, but the horizontal sections of the travel graph represent the time where Lucy is not riding her bike. So we have 1 hour, plus another hour here, so that's 2 hours, plus 1.5 hours here, that's 3.5 hours. So 10 hours minus 3.5 hours gives us a total of 6.5 hours where Lucy has been riding her bike during the day. Question 27b. The table shows the tax payable to the Australian Taxation Office for different taxable incomes. Peter has a gross annual salary of $84,000. She has tax deductions of $1,000 for work-related travel and $500 for stationery. The Medicare levy that she pays is calculated at 1.5% of her taxable income. Peter has already paid $18,500 in tax. Will Peter receive a tax refund, or will she owe money to the Australian Taxation Office? Justify your answer by calculating the refund or amount owed. So let's go through this step at a time. That's a 4-mark question. So the first thing we need to work out is the taxable income. So her gross salary is $84,000, and we subtract the deductions, so $1,000 and the $500 for the stationery. And Peter's taxable income is $82,500, so that's what she will be taxed on. Our next step is to work out her tax liability. In other words, based on this taxable income, how much tax would she owe just based on her income? So $82,500, we need to refer to the income tax table, and it's this row here. So $82,500 lies between $80,001 and $180,000, which means that she will owe $17,547 plus 37 cents for each dollar over $80,000. So it can be worked out this way. So 17,547, so that's from this number here, plus, now 37 cents for each dollar really means 37%. Multiplied by the difference between her taxable income and $80,000, and that's according to this rule here. And so her tax liability will be $18,472. Now we need to work out the Medicare levies. So that's like an extra tax that's added on top, and that is calculated at 1.5% of her taxable income. So we've already worked out her taxable income, so it's $82,500. So her Medicare levy is 1.5% of $82,500, and that's $1,237.50. So that'll be added to her income tax liability to then come up with the total tax that she owes. So the total tax that Peter would owe would be worked out as $18,472 plus $1,237.50 to give us a total of $19,709.50. Now Peter's only paid $18,500 already, so it's a tax paid up front. So the tax that she owes is more than the tax that she's already paid, $18,500, which means that Peter owes more money. So she'll be sent a bill or an invoice from the Australian Taxation Office. So the amount owed be worked out by $19,709.50 minus the tax that she's already paid, and that gives us $1,209.50. Question 27C. A retailer has collected data on the number of televisions that he sold each week in 2012. He grouped the data into classes and displayed the data using a cumulative frequency histogram and polygon, ogive. So part 1, use the cumulative frequency polygon to determine the interquartile range. So I've done part of the solution here, so I'll explain what I've done. The first thing to determine is the total number of scores. And we get that from the end of the polygon here, or just the height of this column. If you project across to the y-axis, we see that corresponds to 52. Next, we need to divide this data into quartiles. So if 52 is the number of scores collected, then 1/4 of 52 would correspond to the first quartile, and 3/4 of 52 would correspond to the third quartile. So 1/4 of 52 is 13, and 3/4 of 52 is 39. Next, we project across from 13 and 39 until we strike the ogive, and then project downwards to work out what the 13th and the 39th scores would correspond to. So the 39th score is 470, the 13th score is 190, and the difference between 470 and 190 would then be the interquartile range, which will be 280. And part 2, Oscar said that the retailer sold 300 televisions in 6 of the weeks in 2012. Is he correct? And give a reason for your answer. Now, if we go back to the question, it says he grouped the data into classes. So we don't know precisely whether 300 televisions were sold or not. That's the group, but it doesn't necessarily mean that that corresponds to exactly 300 televisions sold. So he's incorrect. Data is grouped, which means that individual or specific weekly sales cannot be determined with any degree of accuracy. And the class center of 300 includes sales from 250 right up to 349 televisions per week. So we've got to understand or sort of remember that 300 really represents a group and not a particular number of units sold. Question 27D. A rectangular wooden chopping board is advertised as being 17 centimeters by 25 centimeters, with each side measured to the nearest centimeter. Part 1. Calculate the percentage error in the measurement of the longer side. Now the first thing we need is the precision or the accuracy of the measurement, and that's given in the question. So these measurements are measured accurate to the nearest centimeter. So the smallest unit of measure, or the precision, or the accuracy is 1 centimeter. Now the next thing we need is the absolute error, and that's worked out by taking the precision and dividing it by 2 or multiplying it by half. So the absolute error is equal to half multiplied by the precision, which is 1 centimeter, and that's equal to half a centimeter, or 0.5 centimeters in decimal. Finally, we can work out the percentage error, and we work that out by taking the absolute error, dividing it by the measurement in question, which is the measurement of the longer side, which is 25 centimeters, and then multiplying the result of this fraction by 100, and don't forget to add the percentage symbol at the end, and the answer is 2%. So for part 2, between what lower and upper limits does the actual area of the top of the chopping board lie? And to work that out, we need to know or work out the lower and upper limits of both the width and the length. And to work that out, we need to apply the absolute error. So the advertised length is 25 centimeters, but the absolute error is 0.5 centimeters. So what this means is that the actual length, or the length in reality, varies between 24.5 centimeters right up to 25.5 centimeters. Now for the same reason, the width also varies based on the absolute error. So if the advertised width is 17 centimeters, the absolute error is 0.5 centimeters. So that means that the width in reality could be from 16.5 centimeters right through to 17.5 centimeters. So to work out the minimum area, or the lower limit of the area, you multiply the lower limits of both the length and the width. And the result is 404.25 square centimeters. And to work out the maximum area, or the upper limit, multiply the upper limits of both the length and the width. So 25.5 multiplied by 17.5, and the maximum area, or the upper limit for the area, is 446.25 square centimeters. Question 27E. Karen is in Athens, which is 2 hours ahead of Greenwich Mean Time. Marco is in New York, which is 5 hours behind Greenwich Mean Time. Part 1. Karen is going to ring Marco at 10 p.m. on Tuesday, Athens time. What day and time will it be in New York when she rings? So to help answer the question, I've drawn a number line, and on this number line I've indicated GMT, also known as UTC, and I've given that a value of 0, so that's in the middle of the number line there. Now Athens is 2 hours ahead of GMT, so Athens is written to the right of GMT with a value of +2, and Karen is in Athens. And New York is 5 hours behind GMT, so New York is written to the left of GMT, and I've given it a value of -5. And of course, Marco is in New York. So the time difference between New York and Athens can be found by finding the time difference between New York and GMT. So between -5 and 0, there are 5 hours. And between GMT and Athens, there's another 2 hours. So 5 hours plus 2 hours gives us 7 hours. So Athens is 7 hours ahead of New York, or we can say that New York is 7 hours behind Athens. So Tuesday, 10 p.m. in Athens, if we subtract 7 from 10 p.m., corresponds to Tuesday, 3 p.m. in New York. So part 2, Marco is going to fly from New York to Athens. His flight will leave on Wednesday at 9 a.m. New York time and will take 11 hours. What day and time will it be in Athens when he arrives? So since we're interested in the time that he arrives and reference to Athens time, it makes sense then that the first thing we need to think about is to convert the New York time, or the time when Marco leaves, which is reference to New York time, to Athens time. So Wednesday, 9 a.m. in New York, if we add 7 hours to that, that corresponds to Wednesday, 4 p.m. in Athens. So as soon as the plane takes off in New York, Corinne in Athens will look at our watch and go, oh, it's 4 p.m., the plane has taken off. And it's Wednesday, 4 p.m. in Athens, the moment the plane takes off. Now we're told here that the flight takes 11 hours. So now that everything is referenced to Athens time, all we need to do is just add 11 hours to this time here and then work out what day and time the plane arrives in Athens. So Marco leaves New York on Wednesday, 4 p.m. Athens time, and the flight takes 11 hours. Again, we can visualize this with a number line. Now, I've drawn a slightly different number line here. So in the middle here, I've indicated midnight, 12 a.m., and it's Wednesday on this part of the number line. So this is Athens time, and obviously past midnight, it becomes Thursday. So Wednesday, 4 p.m., the plane takes off and takes 11 hours, obviously to fly from New York to Athens. So from 4 p.m. to midnight, that takes 8 hours. And from midnight plus 3 hours, so that gives us the total flight time of 11 hours, 8 plus 3, to give us our 11 hours, means that the plane will land in Athens at 3 a.m. on Thursday. So Marco lands in Athens on Thursday at 3 a.m. Athens time. Question 28a. A compass radial survey of the field ABCD has been conducted from O. Find the area of the section ABO to the nearest square metre. So section ABO is this triangle, and to find the area of that triangle, either we use half base times height, but clearly we don't have the height, or we can use half AB sine C if we have two sides, or two known sides, and the angle in between, or the included angle. So we have two known sides, we just need this angle here. There's two ways we can find that angle. So this is angle AOB. Either find the number of degrees from point A to north, and then from north to point B. So 310 to north, that's 50 degrees. 50 degrees plus 21 degrees is 71 degrees. Or you can find the reflex angle, so this is the angle here, and then subtract that from 360 degrees, and that will also give you the angle AOB, the included angle in the triangle. So we're going to apply the area rule for triangles. So firstly, we need to think of a strategy. The strategy is this strategy here. Next, I'm going to find reflex angle AOB. So that's 310 minus 21. So 310 minus 21. And that equals 289 degrees. So to find the non-reflex angle AOB, or the included angle in the triangle, it's 360 minus 289, which equals 71 degrees. So now that we have the included angle and the two known sides, we can now apply the area rule for triangles to find the area of triangle ABO. So area of triangle ABO is equal to half multiplied by 75 multiplied by 60 multiplied by the sine of 71 degrees, which equals 2,127.416 square meters, but we need to answer to the nearest square metre. So that equals 2,127 square metre, correct to the nearest square metre. Question 28b. Ahmed collected data on the age A and height H of males aged 11 to 16 years. He created a scatter plot of the data and constructed a line of best fit to model the relationship between the age and height of males. Part 1. Determine the gradient of the line of best fit shown on the graph. Now to do that, we choose 2 points that are some distance apart from each other on the line itself. I'm going to use the 2 endpoints of the interval. So this point here has coordinates 11, 146, and this point here has coordinates 16, 176. Then we apply the 2-point formula to calculate the gradient of the line. So that's the formula, m equals y2 minus y1 over x2 minus x1. Now y2 and y1 correspond to the y coordinates of these 2 points, and x2 and x1 correspond to the x coordinates of the 2 points. And it's very important that we get the order correct as well. So this is x1, y1. This will be x2, y2. So back to the formula. So substituting in those values into the 2-point formula for gradient, we have 176 minus 146 over 16 minus 11, and that gives us a gradient of 6. Part 2. Explain the meaning of the gradient in the context of the data. Now we found in part 1 that the gradient equals 6. But what does that mean in the context of this situation? Now the y-axis represents height, the x-axis represents years. So the gradient represents the change in height per year. So a typical response would be that the gradient represents the height gained per year, which in this case is 6 centimetres per year. Part 3. Determine the equation of the line of best fit shown on the graph. Now the line is in the form y equals mx plus c. That's the gradient intercept version of the line. So let's start off with that. Y equals m multiplied by x plus c. And we know that m equals 6, and we found that in part 1 earlier. So let's substitute m equals 6 into this equation. So now we have y equals 6 multiplied by x plus c. And we need to find c by substituting a known point on the line for x and y. So for example, I could use the point x equals 11, y equals 146, and that's this point here. And then solving for c. So y equals m multiplied by x, so substituting 146 for y, and 11 for x. We have 146 equals 6 multiplied by 11 plus c. 146 equals 66 plus c, since 6 times 11 equals 66. Then we subtract 66 from both sides, or just move this positive 66 from the right-hand side to the left-hand side. So it becomes 146 minus 66 equals c, and hence c equals 80. So that would correspond to the y-intercept. So therefore, y equals 6x plus 80. But to answer the question fully, we need to use the correct pronumerals. Y represents the height h, and x represents the age a. So h equals 6a plus 80. Part 4. Use the line of best fit to predict the height of a typical 17-year-old male. So we're going to use the equation that we found in part 3. H equals 6a plus 80. A represents the age of the male at 17 years of age. So we're going to substitute 17 for A. So H equals 6 multiplied by 17 plus 80. And of course, evaluating that, we get H equals 182 centimetres. Part 5. Why would this model not be useful for predicting the height of a typical 45-year-old male? There are a number of ways to answer this part. Here is my sample solution. The line of best fit is based on heights from ages 11 to 16. Extrapolation beyond those ages is inaccurate and unreliable. Hence, the model is invalid for predicting the height of a typical 45-year-old male. Question 28C. A ship sails due south from Channel Port Basque, Canada, 47 degrees north, 59 degrees west, to Barbados, 13 degrees north, 59 degrees west. How far did the ship sail to the nearest kilometre? Assume that the radius of the Earth is 6,400 kilometres. Now the ship is sailing in a north-south direction, and we can see that by observing the longitude in both of these coordinates is the same. 59 degrees west, 59 degrees west. However, the latitude has changed. So we're starting off at 47 degrees north and ending up at 13 degrees north. So the ship is sailing along a great circle. So we need to know the difference between 47 degrees and 13 degrees. And both of these coordinates, of course, are in the northern hemisphere, since they're both north. We know that the radius of the Earth, or we assume the radius of the Earth, is 6,400 kilometres. So our first step is to determine the degrees sailed. So 47 degrees north minus 13 degrees north is equal to 34 degrees. Now, you just need to be careful that if this was 13 degrees south, this would need to be a plus sign. Now we need to convert this 34 degrees into a distance. And we need to take into account the circle that the ship has sailed on. So the distance sailed is equal to 34 over 360 multiplied by 2 pi, or 2 pi r, but multiplied by 2 pi multiplied by r, and we're told here that r is 6,400 kilometres, and this equals 3,798 kilometres correct to the nearest kilometre. Question 28D. Adele has 2,000 shares. The current share price is $1.50 per share. Adele is paid a dividend of 30 cents per share. Part 1. What is the current value of her shares? That's fairly straightforward. Take the number of shares and multiply it by the current share price. And we get $3,000. Part 2. Calculate the dividend yield. Now it's important that we take note of this word yield. If this word was not there and we're just asked to calculate the dividend, that's a different calculation. We would then take the 30 cents per share and then multiply it by 2,000 to calculate the dividend. But the dividend yield is asking for a percentage, and that's a percentage of the dividend relative to the share price or the current share price. So the dividend yield is calculated by taking the dividend, dividing it by the current share price, multiplying it by 100, and the result will be a percentage. So this equals 20%. Question 28E. Zheng has purchased a computer for $5,000 for his company. He wants to compare two different methods of depreciation over 2 years for the computer. Method 1, straight line with $1,250 depreciation per annum. Method 2, declining balance with 35% depreciation per annum. Which method gives the greatest depreciation over the 2 years? Justify your answer with suitable calculations. Method 1. The salvage value of the computer, or the value of the computer after 2 years, is found by taking the original value of the computer, which is $5,000, and then subtracting 2 years worth of yearly depreciation of $1,250 per year. So 5,000 minus 1,250 multiplied by 2 equals $2,500. So that's the value of the computer after 2 years. So the amount of depreciation is found by taking the original value of the computer and then subtracting the value of the computer after 2 years, the salvage value, and that equals $2,500. Now method 2 is found using the declining balance formula. So the salvage value after 2 years is equal to the original value of the computer multiplied by 1 minus 35%. So when you enter this into a calculator, make sure that percentage symbol is there, of course. And then we square that because it's over 2 years. And that gives a salvage value of $2,112.50. So the computer is worth less using method 2. The depreciation is equal to 5,000 minus $2,112.50. So original value minus the salvage value after 2 years using method 2. And that gives a depreciation of $2,887.50. So clearly method 2 gives the greatest depreciation. Question 29a. Sarah tried to solve this equation and made a mistake in line 2. Copy the equation in line 1 into your working booklet and continue your solution to solve this equation for W. Show all lines of working. So the first line, which is just copied straight from the question, is this equation W plus 4 over 3 minus 2W minus 1 over 5 equals 1. Now our first step is to eliminate the fraction on the left-hand side by multiplying each of these terms by 15. Since by multiplying by 15, that'll eliminate the 3 and the 5 at the same time. So we can write it like this. 15 over 3, so that denominator of 3 just gets moved out to here. Outside of W plus 4 minus 15 over 5, so that's this 5 here. Outside of 2W minus 1 equals 15. That's 1 multiplied by 15 equals 15. Now we can simplify the fractions. So 15 over 3 is 5 and 15 over 5 is 3. So the equation becomes 5 outside of W plus 4 minus 3 outside of 2W minus 1 equals 15. So we've eliminated the fractional component of this equation. Next we need to expand the brackets. So just multiplying through, 5 times W is 5W. 5 times positive 4 is positive 20. Negative 3 times 2W is negative 6W. And negative 3 multiplied by negative 1, negative multiplied by negative gives a positive, and that equals positive 3. And this entire left-hand side, of course, equals 15. Now we can collect the like terms. So we have a 5W and a negative 6W there. And we have a positive 20 and a positive 3. That can be combined. So 5W minus 6W is equal to negative W. And positive 20 plus 3 is positive 23 or plus 23, and that equals 15. Now we can subtract 23 from both sides. So we have negative W as the subject of the formula, and that equals 15 minus 23. And 15 minus 23 is equal to negative 8. And if we multiply or divide both sides by negative 1, we have W equals 8. Now if you have time, it's worth verifying the solution. And we do that by substituting this value of W into the original equation, and then checking that the left-hand side in fact equals 1. So the left-hand side is 8 plus 4 over 3 minus 2 times 8 minus 1 over 5. And evaluating that, we get 12 over 3 minus 15 over 5, which equals 4 minus 1. And that equals 1, which equals the right-hand side of the original equation. So therefore, we are confident that W equals 8 is the correct answer. Question 29b. Ali's class sits 2 geography tests. The results of her class on the first geography test are shown. The mean was 68.5 for the first test. Part 1. Calculate the standard deviation for the first test. Give your answer correct to 1 decimal place. Now for this you can use stat mode on the calculator. So mode. Now on this one it's mode 3. And then number 1 var. And then just enter in the scores as shown. So 58, 74, 65, 66, 73, 71, 72, 74, 62, and 70. Then press AC, and press Shift, and then number 1, and then number 4, where it says var, and then option 3, that's sigma x, that's the standard deviation. It's 5.22, which is 5.2 to 1 decimal place. Part 2. On the second geography test, the mean for the class was 74.4 and the standard deviation was 12.4. Ali scored 62 on the first test. Calculate the mark that she needed to obtain in the second test to ensure that her performance relative to the class was maintained. So the strategy here is to determine Ali's Z-score for test number 1. Then assume that Ali's Z-score for test number 2 is identical to her Z-score for test number 1. And then use the Z-score formula in such a way as to determine her raw score so that the Z-score for test 2 is equal to the Z-score for test 1. So the first thing we're going to do is determine Ali's Z-score for test 1. And using the Z-score formula, it's 62 minus 68.5. So that's her raw score minus the mean for test 1 divided by the standard deviation for test 1. And that equals negative 1.25. Now the next step is to determine the raw score that Ali should achieve such that the Z-score for test number 2 is also equal to negative 1.25. So again, using the Z-score formula, negative 1.25 is equal to Ali's raw score, which at this point is unknown, minus 74.4, that's the mean for the class for test number 2, divided by the standard deviation for test number 2, which is 12.4. And then we're going to solve for x. So I'm going to rearrange this formula, make x the subject. So multiplying both sides by 12.4, we have negative 1.25 multiplied by 12.4 is equal to x minus 74.4. And of course we're going to add 74.4 to both sides so that x is the subject of the formula. So we end up with negative 1.25 multiplied by 12.4 plus 74.4 equals x. So therefore x is equal to 58.9. So let's round that to the nearest whole number. Ali would need to score 59, which is correct to the nearest whole mark. Question 38. Wind turbines, such as those shown, are used to generate power. In theory, the power that could be generated by a wind turbine is modelled using the equation T equals 20,000 W cubed, where T is the theoretical power generated in watts and W is the speed of the wind in meters per second. So part 1, using this equation, what is the theoretical power generated by a wind turbine if the wind speed is 7.3 meters per second? So this one's straightforward. We just take the 7.3, we substitute it for W, we raise it to the power of 3, so 7.3 cubed multiplied by 20,000 will give us our theoretical power. So T equals 20,000 multiplied by 7.3 to the power of 3, and that gives us 7,780,340 watts. Part 2. In practice, the actual power generated by a wind turbine is only 40% of the theoretical power. If A is the actual power generated in watts, write an equation for A in terms of W. So the equation will be 40% of 20,000 W cubed, since 20,000 W cubed is the theoretical power generated. So A is equal to 40% multiplied by 20,000 multiplied by W cubed. So that 20,000 W cubed comes from here, the theoretical power generated. And 40% of 20,000 is 8,000. So therefore, A, the actual power generated, is equal to 8,000 W cubed. Part 3. Using the graph or otherwise, find the difference between the theoretical power and the actual power generated when the wind speed is 9 meters per second. So using the graph, we locate the 9 on the x-axis, so that corresponds to a wind speed of 9 meters per second, projecting upwards until we strike both curves. We want the difference between this point here, the vertical difference that is, between this point here and this point here. So projecting across from these 2 points, we want the difference on the y-axis. And that works out to be around 8.6 or 8.7 million watts. We could work this out numerically, of course, by determining the theoretical power generated and then subtracting from that the actual power generated. So 20,000 multiplied by 9 cubed minus 8,000 multiplied by 9 cubed, and that gives 8,748,000 watts. Part 4. A particular farm requires at least 4.4 million watts of actual power in order to be self-sufficient. What is the minimum wind speed required for the farm to be self-sufficient? Now the formula for actual power is 8,000 W cubed, which we determined in part 2. 4.4 million watts of actual power corresponds to 4,400,000 watts. So we're going to use the formula 8,000 W cubed. We're going to equate that with 4,400,000 and then solve for W. So 8,000 multiplied by W cubed is equal to 4,400,000. Next, we're going to make W cubed the subject of the formula by dividing 4,400,000 by 8,000. So 4,400,000 divided by 8,000 is equal to 550. And then to find W, we take the cube root of 550. So cube root 550, and we get 8.1932 and so on, rounding that to 1 decimal place. We get W equals 8.2 meters per second. Part 5. A more accurate formula to calculate the power P generated by a wind turbine is P equals 0.61 multiplied by pi multiplied by r squared multiplied by W cubed, where r is the length of each blade in meters, W is the speed of the wind in meters per second. Each blade of a particular wind turbine has a length of 43 meters. The turbine operates at a wind speed of 8 meters per second. Using the formula above, if the wind speed increased by 10%, what would be the percentage increase in the power generated by this wind turbine? Our first step is to increase the original wind speed of 8 meters per second by 10%. And we accomplish this by multiplying the 8 by 110%, and that gives us a new wind speed of 8.8 meters per second. Our next step is to determine the difference in power generated when the wind speed is 8.8 meters per second versus a wind speed of 8 meters per second. And we're going to use the formula in the question. So the difference in power generated is 0.61 multiplied by pi multiplied by 43 squared multiplied by 8.8 cubed minus 0.61 multiplied by pi multiplied by 43 squared multiplied by 8 cubed. And that equals 600,502.1596 watts. Now to work out the percentage change, we take the difference in power generated and we divide it by the power generated at the original wind speed of 8 meters per second. So 600,502.1596 divided by 0.61 multiplied by pi multiplied by 43 squared multiplied by 8 cubed. Then multiply that by 100 because we want the answer as a percentage, and that equals 33.1%. Question 30b. In a class, there are 15 girls, G, and 7 boys, B. 2 students are chosen at random to be class representatives. Part 1. Copy and complete the tree diagram in your answer booklet. Now I've completed the tree diagram already. I'm going to explain how I determined these fractions. Now we're starting off with 22 students, so 15 girls plus 7 boys. 2 students are chosen at random to be class representatives. That's without replacement. So when the first student is chosen, that student does not go back into the class to be chosen again. And that's why in the first stage, choosing the first student, it's out of 22. So we have 15 girls out of 22. That's the probability of choosing the first student as a girl versus 7 out of 22 being the probability for choosing a boy for the first student representative. But then when a student is chosen, we only have 21 students left to choose from, and hence why the denominator of the fractions in the second stage is out of 21. So if the first student chosen was a girl, we start off with 15 girls. That means there's only 14 girls to choose from. So the probability of choosing a second girl is 14 out of 21. But there are 7 boys still left to choose from. So if the second student is a boy, that'll be a probability of 7 out of 21 to choose that student, given that the first student chosen is a girl. Now, if the first student chosen is a boy, there's 21 students left to choose from. There are still 15 girls to choose from. So the probability of choosing the second student as a girl will be 15 out of 21. But if the first student chosen is a boy, that means we start off with 7 boys, we now have 6 boys to choose from. The probability will be 6 out of 21. Part 2. What is the probability that the 2 students chosen are of the same gender? Now the outcomes we're interested in are GG or BB. So to get the probability of GG, so 2 girls chosen, we take the probability from the first stage and multiply it by the probability of the second stage. And likewise for outcome BB, so choosing 2 boys, the probability of that occurring is 7 over 22 multiplied by 6 over 21. And here is the calculation. So probability of 2 girls chosen or 2 boys chosen is equal to 15 out of 22 multiplied by 14 out of 21. So that's these 2 probabilities there, plus 7 over 22 multiplied by 6 over 21. So this probability times this probability there. Add those together and that equals 6 out of 11. Question 30C. Joel mixes petrol and oil in the ratio 40:1 to make fuel for his leaf blower. Part 1. Joel pours 5 litres of petrol into an empty container to make fuel for his leaf blower. How much oil should he add to the petrol to ensure that the fuel is in the correct ratio? A very simple way to do this would be to take the 5 litres, divide it by 40, and then multiply it by 1 to give us the amount of oil required. But maybe before we do that, let's convert 5 litres into millilitres, since there's going to be a division involved. And by converting the litres into millilitres, hopefully we can avoid the use of decimals. So 5 litres is equal to 5,000 millilitres. Now to work out the amount of oil, 5,000 divided by 40, since 40 parts corresponds to 5 litres of petrol. So the value of 1 part is found by dividing it by 40, but then we multiply it by 1 because that corresponds to the second term of the ratio. So whatever this number is here, that corresponds to this number here. And that equals 125 millilitres of oil. Part 2. Joel has 4.1 litres of fuel left in his container after filling his leaf blower. He wishes to use this fuel in his lawnmower. However, his lawnmower requires the petrol and oil to be mixed in the ratio 25:1. How much oil should he add to the container so that the fuel is in the correct ratio for his lawnmower? There's many ways of going about this problem, but one way to think about it is, let's find out how much petrol there is left in the container. After all, there's petrol and oil mixed together to create this fuel. This is for the leaf blower. So the amount of petrol left in the container is found by taking how much fuel there is, which is 4,100 millilitres of fuel. So that's the petrol and the oil together. There are 41 parts in total. and that comes from the original ratio, 40:1. And then we multiply that by 40, since there's 40 parts petrol and 1 part oil, and that gives us 4,000 milliliters of petrol left in the container. Now remember that there's oil in the container as well, so if there's 4.1 litres of fuel, 4 litres or 4,000 milliliters is petrol, there must be 100 milliliters of oil in the container, which gives rise to this calculation. So oil left in the container is 4,100 milliliters, so that's the total amount of fuel, minus the amount of petrol that we just determined, and that gives us 100 milliliters of oil left. So now to determine how much extra oil to add. So oil needed for a 25:1 mix, we take the amount of petrol that we have in the container, divided by 25 multiplied by 1, so that comes from the ratio 25:1, and that equals 160 milliliters of oil. But we have 100 milliliters of oil already in the container, so only 60 milliliters extra oil needs to be added to then create a 25:1 petrol oil mix.